we have limit as x approaches infinity of 2x to the 5/3 power minus x to the 1/3 plus 7 over x to the 8/5 plus 3x plus root x. The first thing is we want to identify the highest term of the denominator, and that is clearly x to the 8/5. So I'm going to multiply everything, top and bottom, by 1 over x to the 8/5 power. Now I'm left with limit as x approaches infinity, 2, and now I need to subtract the 5/3 with 8/5. So that would just be common denominator 15. Let's see, 25 minus 24, so that's 1 over 15. So that would be 2x to the 1/15th power minus x to the negative 19 over 15 power plus 7 over x to the 8 over 5th power over 1 plus, now 3x and 1 over x to the 8/5, that would just be 3 over x to the 3/5. And root x is x to the 1/2, 1/2 minus 8/5, that would just be 1 over x to the 11 over 10th power. And actually here, I have x to the negative 19 over 15th. We'll just do this. We'll say it's 1 over this, and now we'll make this into a positive number. So we'll just ignore that, that negative. Okay. So let's see. As x approaches infinity now, we know that this, so everything that I'm circling have the denominator approaching infinity, so that's going to go to 0. So I'm left with limit as x approaches infinity. Now I have 2x to the 1 over 15th power, and we know that as x approaches infinity, so will the 15th root approach infinity. Just at a slower pace than, let's say, x to the 1/2. So here the limit is infinity, and really x to the n, where n is positive, will always go to infinity. So this will always approach infinity. Okay, let's go on to the next one. Okay, let's say we have limit as x approaches negative infinity of cube root of x minus 5x plus 3 over 2x plus x to the 2/3 minus 4. Here I'm going to identify the highest degree, the bottom, the highest term, which is the x. So I'm going to multiply top and bottom by 1 over x. So I have limit as x approaches negative infinity. Now I'm going to distribute the 1 over x to the top, and I'm going to get 1 over x to the 2/3 minus 5 plus 3 over x over 2 plus 1 over x to the 1/3 minus 4 over x. We know that 1 over x to the 2/3, 3 over x, 1 over x to the 1/3, 4 over x will all approach 0. And all that's left is negative 5/2. So my limit is negative 5/2. Okay. Let's say we have limit as x approaches infinity. Now it's square root x squared plus 1 over x plus 1. Here we still identify the largest exponent of the denominator, the highest term, which is x. So we're going to multiply top and bottom by 1 over x. Here we want the 1 over x to go inside the square root. So in order for it to go inside the square root, we're going to rewrite it as 1 over x squared. So we're going to have x squared plus 1. And now the 1 over x will appear as 1 over x squared. And on the bottom, we're going to distribute the 1 over x to get 1 plus 1 over x. And now on the top, we can distribute the 1 over x squared. So the x squares will cancel, and we'll get 1 plus 1 over x squared. And the denominator is just going to be the same. We know that 1 over x squared and 1 over x are going to approach 0. So I'm left with square root of 1 over 1. And my final limit is 1. Okay, that one we got to be a little clever. Now let's see what happens if the square root is on the bottom. So let's say we have limit as x approaches positive infinity of x minus 3 over square root 4x squared plus 25. Okay. So this one, we identify the highest degree, highest term in the denominator, which we know is the x squared. And here, it's really the square root of x squared. So we can, because the x squared is inside the square root, we're going to multiply top and bottom by 1 over x squared. Like that. Which is essentially multiplying by 1 over x. And usually, okay, we know that square root of x squared is going to be absolute value of x, depending on if x is positive or negative. But because we're approaching positive infinity, we're looking at a positive x value. So that reduces x squared to just be x. So we don't have to worry about any negatives. Okay, so let's see. We have limit x approaches infinity. Now x times 1 over x squared is really the same thing as multiplying by 1 over x. So really, I'm just going to write 1 over x in green to show that it's identical, just to make the algebra look nice. And we'll have 1 minus 3 over x at the top. And at the bottom, I can bring the x squared inside. So I'm really just dividing the inside of the square root by x squared. So I'll be left with 4 plus 25 over x squared. And now 3 over x and 25 over x squared are going to approach 0. So I'm left with 1 over square root of 4, which is 1/2. And that's my limit. Okay, let's try another one. I have limit as x approaches negative infinity. Now it's 4 minus 3x cubed over square root of x to the 6 plus 9. Okay, first step is identify the highest term in the denominator, and that's the x to the 6th term. But it's inside the square root. So I'm going to multiply top and the bottom by 1 over x to the 6th. And now I'm looking at x approaching negative infinity. So before we said the square root of x squared is absolute value of x, but the square root of x to the 6th is also absolute value of x cubed. And since we're approaching negative infinity, this reduces to negative x cubed. Okay, so we're going to think of it as negative x cubed. So at the top, I can just rewrite it as 1 over negative x cubed. And that's identical. Okay, so the bottom, so let's see. The top, we have 4 times negative 1 over x cubed, which will be negative 4 over x cubed. And the x cubes will cancel. We'll get plus 3. The bottom, okay, so the bottom, we can bring the square root x to the 6th inside. So we're really dividing the inside by x to the 6th. And we see that, okay, this goes to 0, and so does this. And so we're left with 3 over root 1, which is 3 as our final limit.